Morena. Morena. Ata mairi kia tātou katoa, ko Dr. Diana Kopua tēnei, e mihi kauana kia koutou katoa e whakarongo ana I tēnei ata kei tūranga nui a ki wā hau. E pānui ana tēnei puka puka. And this book was by a psychiatrist called Joanna Moncrief. She is a critical psychiatrist, and as I've said earlier, I am connected to a critical psychiatry network, mostly from UK and those areas, but there are a few from Canada, New Zealand, and America. I can't remember what number I'm up to here, but I'm on chapter 2 of this book, and it's called How Do Psychiatric Drugs Work? And I'm just gonna, sorry, I missed commenting on your kōrero yesterday, and so I'm going to just arrange it so I can see your comments. Morena make, morena. Hope your training's going well. Morena. Kia ora. Okay, let's take this. Let's just rush back. Here we go. If you haven't had an opportunity to read some of the other sessions, then kei te pai, you'll get something out of any of the readings, and hopefully we'll be able to layer those in the future. As described in the previous chapter, Western psychiatry portrays the behavioural disturbances and emotional suffering that it encounters as diseases or illnesses. It suggests that these disturbances arise like other medical diseases from a disruption in the smooth running of some part of the body, usually the brain. Over the past 2 centuries, there have been numerous attempts to identify physical causes for madness and distress, with different theories going in and out of fashion. The idea that psychiatric disorders are genetically transmitted has been popular for a long time, and birth complications, viral illnesses, structural brain defects, and imbalances in brain chemicals have all been proposed over the years to be the cause of certain mental disorders. Do psychiatric drugs treat diseases? Because psychiatric problems are believed to be diseases, it is usually assumed that the major types of drugs used in psychiatry work by reversing or partially reversing the underlying disease process. The naming of psychiatric drugs reflects this assumption. So antipsychotics are thought to act on the biological abnormality that produces symptoms of psychosis or schizophrenia. Does that make sense? So the antidepressants are thought to reverse the biological basis of depressive symptoms. Does that make sense? So you go to the doctor, you think you have depression, and so you sort of think maybe those antidepressants are what you need. And when you think about it, why do you think that that's what you need? An antidepressant, maybe it treats depression, right? In the same way an antihypertensive treats hypertension. That's what we would think, right? Mood stabilizers are thought to help rectify the process that gives rise to extreme fluctuations of mood, and anxiolytics are thought to address the biological mechanism that creates anxiety. Stimulants, so anxiolytics, remember anxiolytics are things like benzodiazepines, so diazepam, clonazepam, and now even the SSRIs that we talked about earlier. And stimulants are said to be specifically counteract the biological basis of ADHD, attention deficit hyperactivity disorder. This view of the nature of psychiatric drugs can be called the disease-centered model of drug action. It could equally well be called the symptom-centered model, because it does not necessarily suggest that drugs target the ultimate cause or root of the disease, just that they act on the biological mechanisms that produce various symptoms of mental disorders. Although the disease-centered model is now the dominant view of what psychiatric drugs do and how they work, it only developed relatively recently during the 50s and 60s. The disease-centered model is based on the same logic that is used to explain the action of drugs in the rest of medicine. Although few medical drugs reverse the root cause of a disease, most act to reverse or partially reverse some of the biological processes that produce the symptoms of the disease. Psychiatrists often compare the need for psychiatric drugs to the use of insulin in diabetes. For example, insulin treatment does not reverse the root cause of diabetes, which is the failure of the body's pancreas gland, but it doesn't help reverse the consequences of the disease by replacing the body's failing insulin supply. Does it make sense? So they're just trying to let you know how the disease-centered model of drugs works, and they're using diabetes as an example. So giving someone who's diabetic insulin doesn't treat the underlying root cause, which is the pancreas. The pancreas isn't able to keep up with the supply of insulin. So the disease-centered model for this drug, insulin, is to try and prevent some of the resulting consequences of diabetes. Right, so anti-asthma drugs like salbutamol, Ventolin, also act in this way. Although they do not target the underlying cause of asthma, they work by relaxing the restricted air passages in the lung and thereby alleviate the symptom of wheezing. In this sense, most drugs used in general medicine act according to a disease-centered model. This is no accident, since medical drugs are developed to target, I'm lost. This is no accident, since medical drugs are developed to target identified disease processes. They are effective because they act on the biological mechanism responsible for the particular symptoms that are designed to treat. The disease-centered model of drug action is closely related to theories that suggest that psychiatric conditions are caused by abnormalities in particular brain chemicals. In popular terms, these ideas have come to be known as the chemical imbalance. And it's the chemical imbalance theory of mental disorder. We now know that the brain contains many chemical substances that help to transmit messages between the nerve cells that make up the brain. These chemicals are called neurotransmitters and include substances like dopamine, noradrenaline, serotonin, acetylcholine, endorphins, histamine, and more. They are involved in helping the electrical impulses that travel along the nerves to cross the gaps between the nerve cells, which are known as synapses. When the electrical impulses arrives at the terminal of one nerve or neuron, it causes the release of a neurotransmitter from the sacs or vesicles in which it's stored. The transmitter travels across the synapse and attaches to receptors on the surface of the adjacent neuron. Ooh, I might be losing you, hang on. The bonding between the neurotransmitter and the receptor activates or sometimes inhibits the nerve's impulse in the second nerve cell. Many psychiatric drugs act on the receptors, either blocking or enhancing the receptor ability to transmit impulses. The neuroleptic or antipsychotic drugs, for example, block various combinations of dopamine, noradrenaline, histamine, serotonin, and some other receptors, and stop the related neurotransmitter chemicals, including dopamine, from transmitting their messages in a normal fashion. Opiate drugs like heroin and morphine stimulate receptors that are usually activated by the body's natural pain-killing chemicals, the endorphins. Okay. Drugs can also affect neurotransmitters in other ways, such as directly stimulating their release, inhibiting or facilitating their action in various ways, or acting on the mechanisms by which they're activated or removed from the synapse. Okay, so Joanna's clearly giving us some ideas about what we know in the brain about messages being shared from one nerve to another through these neurotransmitters, these chemicals, and she's named some of them. And the reason she's naming them is because these are the theories behind why we give you these medications in psychiatry. So one of the ways in which neurotransmitters are inactivated is by their reabsorption or reuptake and into the nerve cells. Antidepressants are thought to act by stopping the reuptake and deactivation of the neurotransmitters, the serotonin and noradrenaline, leading to an increase in the level of these chemicals in the synapse. So before I talk about her, she's going to talk about, oh no, I'll carry on. However, as explained in chapter 5, it's not been demonstrated that these drugs reliably increase the level of transmitters. Excuse me. Stimulants like amphetamine and Ritalin directly stimulate the release of noradrenaline and dopamine into the synapse and reduce their reuptake from the synapse. Benzodiazepine drugs, diazepam, Valium, act in a similar way to control to alcohol by increasing the effects of the inhibitory neurotransmitter known as gamma aminobutyric, I don't even know how I'm saying that, acid, we call it GABA. It should be stressed, however, that we remain uncertain about the precise mechanism by which most drugs that act on the brain produce the characteristic physical, mental, and behavioral effects that they do, and few of them are likely to act through a single mechanism. Think about that. Following the observation that psychiatric drugs act on neurotransmitter systems, which was first documented in the 60s, it started to be proposed that an abnormality in these systems might be the cause of psychiatric disorders. The best known example of this way of thinking is the dopamine hypothesis in schizophrenia. The idea that depression is caused by a deficiency of serotonin or noradrenaline is another example, sometimes referred to as the monoamine theory or depression. Serotonin and noradrenaline are both classified as monoamine type neurotransmitters. See how language can disconnect us from the kaupapa. Although scientists acknowledge that these are merely theories, which are far from being proven, there is a widespread public perception that the biochemical origins of various psychiatric disorders have been established. The key here is that they haven't, and that we can't, we don't know exactly the impact of these neurotransmitters, whether there's too many or not enough, and we don't know the impact on our physical and mental and behavioral ways. And so there isn't any proven evidence that psychiatric problems are due to any biological mechanism. So when I'm in a room with people who are in distress, and the way that I used to let them know how the medication works, when I really believed in everything, and I didn't believe in everything that I was listening to, but when you're a student and you are faced with learning a complex model or concept, and you can't get your head around it, you can't remember the names, and you can't commit it to memory, when you finally do, it's like, yay, I've remembered it. Never mind the fact that it's actually not necessarily factual information. So let me just tell you what they talked about in summary. So there's a nerve cell and there's a nerve cell, and there's a space in between my fists, in between the nerve cells, called a synapse. It's a space called so the space is called a synapse. And there are these chemicals that sit in these vesicles that hang around. And so an electrical impulse will travel through the nerve cell, and it will stimulate a release of those chemicals. And some of those chemicals, let's say serotonin, they will be released out of their sac, out of the nerve cell, and into the space. And what they do is they act like keys to trigger a response, and sit a key that fits in the keyhole here, triggering a response and a nerve impulse here. So the theory is when we're depressed that we don't have the flow of electrical impulses, and therefore we become depressed. You know, the lack of sleep, the low mood, lethargy. So that's the theory. And so the drug, the way that the theory is that if I block the reuptake, because their nerve cells are very, very considerate of their environment, and they always, once the serotonin has triggered here, they'll be recycled back up into this nerve cell and put back into those vesicles. But the antidepressants, what they do is that they block the ability for the serotonin to be taken back up, and therefore there's more serotonin in that space, so more chance of the nerve cells being triggered. That's the theory. Now, I only said that so that you understood all of that babble, all of that talk. And if you heard the introduction, we talked about mental health problems being everyone's problem. But when people start talking like that, you see why we just start leaving it to the experts. That's me, the psychiatrist. So, and what we're saying is that actually mental health problems aren't necessarily illnesses. In fact, I like to challenge the idea that they're not. It might exclude the dementias, and if mental health problems aren't illnesses, then it means that everyone has a stake in thinking about how we progress as a society, living in a world where more and more of us are experiencing mental distress. Morning, everyone. So I'm done this morning, so hopefully I'll just check to see if there's any questions. Yay. Oh, kia ora. Morena, 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 everyone. Morena. Kapa, everyone. I'll carry on with chapter 2. And that was a bit heavy, eh? But anyway, we'll start tomorrow looking at are mental disorders caused by a chemical imbalance. So you've got a little bit of an idea about the chemicals and the theories. And so we'll see you. Popo, ka kite.